So can you tell me something that you notice about both of these graphs? What do you notice about both of these graphs? Something they have in common. They both have positive degree or positive leading coefficient, and they both have even degree. Tell me something about how that you think is impacting the shape of these graphs. They're facing upwards and they're both pointing in the same direction, right? So now, I don't have these graphs drawn, but you have graphs 3 and 4 drawn. Both of them had a degree that was even again, right? Right? A degree of 6 and a degree of 4. And they both had a leading coefficient that was what? Negative. What is the shape of both of those graphs? They're both concave down. I didn't draw them on my own paper, so I'm kind of copying a little bit. So here's Tessa's rough sketches, if I am looking at the right graph. Something like that. They're both facing down with both of their arms. So that's something they have in common. We're going to generalize this in a minute. Turn to the next page. Number 5 and 6, what did they have in common? They both were odd degree, and they both had a negative leading coefficient. So let me generalize something for you. The right side of the graph should be pointing down, or sorry, the right side is pointing down, the left side is pointing up, right? I don't have this graph, so I'm not sure what the middle part looks like, but can you agree that that's true for both of these graphs? Yeah. There's some squiggle or it cuts through, but down on the right, up on the left. The ones down at the bottom, they both were odd degree again, odd, but this time they went up on the right and down on the left. And I'm not sure what it did in between. You have your graph to look at. So there's something that is happening called end behavior in all of these graphs. So the general idea is that, let's see, I didn't read these questions. Graph number 1 has the right side of the graph going up towards positive infinity. What other graphs have their right sides going up? So we already said number 2. And then number 7 and 8. Right? So which had the right side going up? 1, 2, 7, and 8. So it was every time that the leading coefficient was positive. So the leading coefficient sends the right side of the graph up. So leading coefficient has a different job than the degree. Number 11 is really asking about the degree. What do all the graphs on the front page have in common? They were all even functions or degrees, and these were all odd. Right? So both ends point in the same direction. So if you were going to do the polynomial dance, right, your hands both go up or your hands both go down. The odd functions went in 2 different directions, right? So the degree of the function on the front page was even versus odd. I kind of already summarized all that for you. So here's the summary. So here's kind of what you need to have memorized, or I'm going to show you a trick so you don't have to like memorize something new. It kind of goes right along with quadratics. We already know this from quadratics. When the leading coefficient is positive, the right side goes up. When the leading coefficient is negative, the right side goes down. Oops. We already know that from quadratics, right? Concave up when it's positive, concave down when it's negative. That shouldn't really be something new that you have to memorize. Here's something that might be new. When the degree of the function is even, so I should say like x squared, the left side goes the same direction as the right side. When the degree of the function is odd, so like x or x cubed, the left side goes the opposite direction. I could say different, I guess, same or different. So we need to be able to look at a function and decide, is the right going to go up or down? And should the left side go same or different, or same or opposite? Without even looking at a calculator. So you're going to be able to sketch a graph using the zeros of the function, something called the multiplicity of the zeros that we're going to learn about today, the end behavior, and the y-intercept. So you know a lot of information. You don't need the graphing calculator for a rough sketch. So on this back page, now here are your functions. So let's go through. We want to identify first the leading coefficient, because the leading coefficient's job is going to tell you something. So in number 1, what's the leading coefficient for number 1? What number is the leading coefficient? 1. You would just want to check that it's in standard form before you identify the leading coefficient, but x squared is the highest term and 1 is its coefficient. So if it's positive, what does that tell you about the right side of the graph? It's going up because 1 is a positive number. All right, let's do the left side of the graph. What is the degree of function number 1? The degree is 5. Is 5 an even or an odd number? 5 is odd, last I checked. So what's going to happen with the left end? Are they both going to go up, or is one going to go up and the other one's going down? Odd. Odd and opposite both start with the letter O. So if the degree is odd, like x cubed or x to the 5th, the left side has to go in the opposite direction, up on one side, down on the other. See if you can follow those rules for number 2 and 3 the same way. You look at the coefficient first. So the right end is the leading coefficient, and then the degree tells you what the left side is doing. So use the leading coefficient, make sure you're in standard form. So take a minute, try 2 and 3. We'll check our answers before we do 4 through 6. Heuristics. And I realized that I never unpaused. So I'm going to go back up to the top to show people watching the video that the leading coefficient was -2, so the right side went down. The degree was odd, opposite. They go in opposite directions. And in number 3, the leading coefficient was +1, so the right side goes up. The degree was even because it's 10, so the left side mirrors the right side. So now we are sketching graphs that fit these characteristics. All right, so you check your own answers. Number 4, as long as both ends of your graph pointed up, you're in good shape. But you could have done a W shape like this. I mean, there's multiple answers for that one. But as long as both ends are pointing up. On number 5, as long as you've got down on the right, up on the left. But you could have had something like really squiggly like that. That would work. You could do several, turning points in the middle. As long as you've got up on the left and down on the right. And then opposite for number 6, up on the right, but down on the left. But you could have several turning points if you wanted to. You could just have like plain old x cubed. That would be fine. You could even have a linear function, right? Because a linear function is still a polynomial function. Okay? Stop.